Section 2.6, Addition and Subtraction with Fraction. Now you're going to see the reason why we found the LCM earlier. Okay, what we're going to do here, we're going to add fractions with same denominator and add fractions with different denominator, and then we're going to do the same thing with subtraction. Let's come here, look at a kind of procedure here. Okay, procedure, add the numerators. Okay, keep the common denominator. Notice if we have a common denominator, we can just come straight in here and just start adding. Okay, and always remember, the b, the bottom here, the denominator, cannot equal 0, and then reduce if possible. Then it gives an example here. And notice, this is for something of the same denominator. So let's come in here, and we'll do a couple of examples here. Okay, we've got 4 over 15 plus 6 over 15. Well, let's go ahead and do the math on that. Notice here we have the same denominator. Whenever you have the same denominator, you don't got to get freaked out. You can just come straight in here and just start doing your addition process. So 6 plus 4, that's going to be a 10. Okay, and then 15 over 15. Do not add these. Okay, we're just going to go ahead and just put the 15. Just keep the denominator. Notice here that you can divide the top and the bottom by 5. So if I divide top and bottom by 5, I'm going to end up getting 2/3. Okay, let's continue on. Okay, I've got 1 plus 5 plus 3. Well, that's going to give me an 8 and a 9. Okay, so I've got 9 here, and then I've got an 11. Okay, I'm not going to worry about the bottoms here. Notice that 11 is a prime number, so you're pretty safe about this not going to match up. Okay, so this is going to be in simplest form there. Okay, let's do another one. Okay, let's find the LCD for 10 and 12. Okay, what's going to happen is we need to find the least common denominator. You've just done that. That's the LCM. Okay, so this can be right here. You can think of this also as the LCM. Okay, so we need to come in here and go and do the prime factorization of 10. Well, that's just going to be 2 times 5. Well, how about 12? Well, we can have 2 times 6, but then 6 is going to be 2 times 2 times 3. And so therefore, notice that all my factors of this are going to be 2, 3, and 5. Well, how many was the largest number of 2's I have? Well, that's going to be right here. So I have 2 times 2, okay? And then I have a 3, and then I have a 5, okay? Well, 2 times 2 is 4, okay? 4 times 3 is 12. And then that's going to be 5 times 12. That's going to be a 60. So my least common multiple, or LCD, interchangeable, is going to be 60. So why do we need that? Well, here's why. To add fractions with different denominators, find the least common denominator, LCD. Okay. Change each fraction to an equivalent fraction with that denominator. Okay. Add the new fractions, and then reduce if possible. Okay, coming in here, we've got one that I've already pulled up as an example for us. Okay, we got 3/8 plus 7 over 12. Step 1, find the LCD. Notice for 8, 2 times 2 times 2 is going to be our 8. 2 times 2 times 3 is going to be our 12. Notice we have 3 2's here and just 1 3. Okay, so we can do all of this right here, which we've done. Okay, 2 times 2 times 2 times 3 is going to be 24. Great. Now what we need to do is notice here that we've got this 2 times 2 times 2, but I've got this 3 down here, okay, which is going to give me a 3 here, 8 times 3. Okay, here, 2 times 2 times 3 times 2. Well, notice I don't have this 2 down here, so I need to take this 2 and bring it down here, okay, which gives me 12 times 2. Okay, there is an easier way to think of this. Notice, my LCD is 24. Come in here and go, okay, if my LCD is 24, well then what I need to do here is how many times will 8 go into 24? You can come in here and go, well, what's 24 divided by 8? Well, that's going to be 3. Well, how about 24 divided by 12? That's going to be the 2. Okay, and then what I do is this. I would come here and write it like this. I got 3/8 plus 7 over 12. Okay, well notice for the 8 that there's a 3 here. Well, that means I need to multiply everything here by 3. Because it's algebra, notice what I do to the bottom, I have to do to the top. Come in here, and then I can do the same thing here. Okay? So when I do this, okay, well 3 times 3 is 9. I know I'm going to have that 24 on the bottom. Then I got plus, then I got 14 here, and then I got the 24. Now notice that I have created a common denominator, okay? And now I can just add these like normal, okay? So 14 plus 9, well, that's going to give me 23. And then I've got to just keep the 24 on the bottom. And then that's going to be my final answer for this one, okay? I get why they do this part here, but I think this part, doing it this way, is so much more simple. Okay, let's look at a common error here. The following common error must be avoided. Okay, add 3/5 plus 1/15. Notice, don't start reducing. Okay, like we did with subtraction, or not subtraction, like we did with multiplication and division. You can't do that. Whenever you have a plus here, you cannot start reducing crosswise. You can reduce up and down, okay? Like, I could reduce out of this fraction here, or this fraction here, but I can't go diagonal, okay? You just can't do it. You have to do it this way. Once you get it to a point where you can come in here and start reducing, you can. Like, notice how there's multiplication happening here. That can happen, but until then, no, can't do it. Okay, let's come in here. Let's do another example here. Okay, I've got 7 over 45 plus 7 over 36. I cannot add these together right now because notice I don't have a common denominator. Okay, so let's find our least common denominator, or LCM, however you want to call it. First off, we're going to go ahead and prime factorize that. Do the prime factorization of both numbers. So I've got 3 times 3 times 5. Here I've got 2 times 2 times 3 times 3. Well, notice on my 3's, okay, I have the same amount of numbers. Okay, then I've got 2 2's and a 5. So the prime factor, whenever I multiply all these together, I'm going to get 2 times 2 times 3 times 3 times 5. Okay, let's do the math on that. We've got 2 times 2 times 3 times 3 times 5, and we're going to get 180. Okay, well, I'm just going to do this the way I'm going to show you how to do it, the way I like it. Instead of having to come in here and start worrying about where am I going to pull in another, no, let's just do this. How many times will 45 go into 180? So let's do 180 divided by 45, and then let's do 180 divided by 36. So I've got 180 divided by 45, and that gives me a 4. 180 divided by 36, and that gives me a 5, which means that notice on the 45, to make it 180, I have to multiply by 4. So I can come in here and go 7 over 45. Well, to make this guy right here a 180, I have to multiply it by 4. What I do to the bottom, I have to do to the top. Then I've got plus. Now I've got this other 7 over 36. Notice he's a 5. So I'll come in here, multiply everything by 5. Continuing on, 7 times 4 is going to be 28. And then I know I'm going to have 180 on the bottom. Okay? Plus 5 times 7 is 35. Okay? And then I know I'm going to have the 180 again. So then I can go and add, because notice now I have common denominators. I can do 35 plus 28, and that gives me 63 over 180. Well, now if you want to, you go and come in here and start, you can prime factorize this out. You can start testing things out. If we decide to prime factorize this out, notice the prime factorization of 63 is going to be 3 times 3 times 7, okay? And then the bottom is going to be 2 times 2 times 3 times 3 times 5, which we should know that because most that's how we got that 180. Well, I can come in here and notice that, well, I've got a 3 here, a 3 here, 3 there, a 3 there. Well, then notice on top, I'm just going to be left with the 7. Okay, on the bottom I have 2 times 2 is 4 times 5, that's going to be a 20. So my final answer here is going to be 7/20. Okay, let's continue on. Now we want to know some properties that we know of whenever it concerns addition of fractions. Okay, and the commutative property still holds true. Remember when we were doing whole numbers, commutative property says I can switch these guys and it works. The only addition to this is right here is just remember B and D can't be 0. That's going to be something that I'm going to say a lot of. Remember that the bottom cannot be 0. Okay, but the commutative property still holds true. I can flip these around in whichever way I want, and it still holds that no matter what, I can go ahead and add them up. They're going to be the same thing. Same thing with the associative property. Remember, that's the grouping. Okay, I can group here or I can group there, but it's always still going to equal the same thing as long as I'm very cognizant of, notice that not equals 0 on the bottom. Okay, so we kind of see an example of that right here. Now we're going to look at subtraction. Subtraction works exactly the same way. Okay, exactly. Okay, we're going to have to find a common denominator if we don't have it, and then you just do the subtraction as normal. So let's come in here and let's do an example of 1. Okay, we've got the subtract 9 over 10 minus 2 over 15. Notice we find the common denominator. Okay, first off we factorize. Okay, and then we get 30. Okay, then notice that once we find the 30, we can come here and go, well, how many times will it take for 10 to become 30? So I can go and rewrite this as, notice, 9 over 10. Well, to get that to 30, I need to multiply by 3. Bottom and top. Then subtract 2 over 15. Well, it takes a multiplication of 2 to get that to 30. And what I do the bottom, I have to do the top. Well, right here, I've got 9 times 3, which could be 9, 18, 27 over 30, minus 2 times 2 is 4. And then we're going to have the 30 on top. So when I do 27 minus 4, that's going to give me a 23. And then all over 30. Okay, and so that right there will be our final answer. Notice that this worked out exactly the same way as it did with addition. One thing to note is, remember, going back to our properties, that I can't just pick and choose and switch these around, okay, like I did with addition. Okay, I cannot put this to this 4/30th minus 27 over 30. Doesn't work that way. Okay, subtraction is not commutative.